Hello everyone. So today we will be learning chapter 2, exploring data with tables and graphs. Okay. So here we will have 4 sections. In chapter 2 we have 4 sections: 2.1, 2, 3 and 4. Okay. So in 2.1 we will be studying about frequency distribution table. In section 2.2 we will study about histograms, and in 2.3 we will study about graphs, and in 2.4 we will be studying about scatter plots, correlation and regression. Okay, so let's get started. So in chapter 1 what did we learn? In chapter 1 we learned about certain terminologies, right? And we also learned mainly about data collection and sampling types and so on, right? So in chapter 2 we will mainly be learning about ways to organize and describe data set. So the goal is to make the data easier to understand. Okay, for example, I have a raw data. For example, we have a raw data showing the ages of 50 people, of some 50 people. So let's say the data is like this. Okay, this is the raw data. Now, if I ask you to tell how many people have the age of 90, you have to start from the beginning and you have to check each and every value whether it is equal to 90. So here it is 1 and 2. So 2 people as the age equal to 90. Now here the data is very small, right? And that is why we were able to find out how many people had the particular age. What if you have many data, like if your data set is very large, what will you do at that time? To organize the data, to organize and summarize the data, we have two things, that is histogram and frequency distribution table. So we will learn about this in this section, and in the coming section we will learn about histogram. Okay. So in this chapter you will mainly be learning about how to construct. You must learn about constructing the frequency distribution table, and you must be able to find out or compute limits, midpoints, so on. Okay, so you must be able to do this in this chapter at the end of this section, I can say. Okay, so now frequency distribution. What is frequency distribution? So a frequency distribution is a table that shows classes or intervals. Okay, it is a table which shows classes or intervals of a data entries with a count of the number of entries in each class. Okay, and the frequency in the frequency distribution, that is nothing but a number of data entries in the class. Okay, frequency is the number of data entries in the class. Okay, what is the frequency distribution table? It is a table which shows classes or intervals of the data entries. Fine. Now, why do we need this frequency distribution table? As I said earlier, when you are working with a large data set, frequency distribution is very helpful to organize and summarize data. And we can also understand the nature of the data set. We can also understand the nature of the data set, and that is why frequency distribution is important and it is very helpful. Okay, now I had an example here. Okay, now let's learn about certain definitions. Okay. Lower class limits. The smallest number that can belong to each of the different classes is called lower class limit. So let me explain all these terms with an example. So here you have a frequency distribution table. This is called as class. Okay, this column is called as class, and this is a frequency. What is a frequency? It is the number of data entries in the class. Number of data entries in the class. Each of this number is called a frequency. Okay, now this whole thing is the frequency distribution table. This whole thing is called frequency distribution table. Okay, now let us find out the lower limit. What is the lower limit? It is simply a least number that can belong to the class. So which is the least number which belongs to this class? It is 1, right? And in this class it is 6. In this particular class it is 11. All these numbers are nothing but your lower limit. Lower limit. Okay, and the numbers here, this is called as upper limit. It is nothing but the greatest number of the class. Okay, next, what is class width? What is class width? Class width is nothing but the distance between your lower limit of the consecutive classes. Okay, the distance between 1 and 6 here. This distance we call it as class width. Okay, now we also have a formula for that. It is maximum minus minimum divided by number of classes, divided by number of classes. So in this case What are the number of classes? 1, 2, 3, 4, 5, 6. So here number of classes is 6. What is the maximum value? 30, right? See, maximum value is 30. All this are called as this. So this is the maximum value and this is the minimum value. One is the minimum value. So your maximum value is 30 and your minimum value is 1. So this is 30 minus 1 divided by number of classes, which is 6, which is nothing but 29 by 6, which will be approximately 5. Okay, you will get a decimal. You have to round it off to the nearest integer or a convenient number. Okay, now next term is range. What is range? It is nothing but maximum minus minimum is called as range. So here it is 30 minus 1, 29 is the range. Now, next thing is class midpoint. So class midpoint is nothing but lower limit plus upper limit divided by 2. Now, if I want to know the class limit of this class, of the first class, I will have to add number 1 and upper limit is 5. So it will be 1 plus 5 divided by 2. That will be my class midpoint. That is how you find the class midpoint. Okay. So these are certain definitions which you will have to know before constructing the frequency distribution table. Okay. Now let's see how to construct this table. Fine. So first thing is we need to select the number of classes. So usually number of classes will be given in your problems, examples. So you don't have to worry about that. If not, you have to select that classes between 5 and 20. Why? Because if you do not select a number of classes between this range, then it might be difficult to detect any patterns in your data set. Okay, that is why we choose a number between 5 and 20. Now, how do you calculate the class width? I already told you about this formula, right? So first step is to select a number of classes and then calculate the class width using this formula. And you remember, you have to round this off to the convenient number so that it will be easy for our further calculations. And next, you have to find the lower limit of that raw data and then you have to add this class width for each number and then you can create classes. Okay. Once you create all the class values, and then is to find the frequency. What is frequency? Frequency is nothing but the number of classes, right? So once you find the class limit, using these 3 steps, next step is to find the frequency. How do you do that? Using tally. Okay, so let's understand this with an example. Right? So this is the raw data. So what is step 1? As I said you, step 1 is to find the number of classes, right? Number of classes. So in this problem, if you read, it's already given. They say that we have to use 5 classes. So number of classes is 5. Step 2. Once you find the number of classes, next step is to find the class width. Class width. What is the formula for class width? It will be equal to maximum data value minus minimum divided by number of classes, right? So in this if you see, what is the maximum data value? It is 308. 308 is the maximum data value. And what is the minimum? It will be 83. This is the minimum data value. Okay, so class width is nothing but 308 minus 83. Number of classes is 5, which will give you 45. Now usually we will round it off to the nearest integer or a convenient number. So I can choose this as 50. Okay, you can round it off to 50, or even if you keep in the same number, there is not much difference found in the values. Okay, so I'm just rounding off to 50 so that since it's a 0, the calculations will be more easy to do. Okay, now step 3 is to do the class limits, right? So how do you calculate the class limit? You have to first find the lowest number in the raw data. So what is the minimum number in the raw data? Minimum value is 83. Now I can choose this as 80, or I can choose it as 75 also, just for the convenience. Okay, now once you choose the minimum value, next step is to add class width. Okay, add class width to minimum value. Add class width to the minimum value. Okay, so minimum value will be 75. I'm just choosing it as 75. Minimum value is 75. I will be adding 50 to this. Let me draw a table and then, okay, so we are constructing class limit first. First thing is what? We have a lowest number, which is 83. So instead of 83, I can choose it as 75 also, or you can also choose it as 80. It should be less than the minimum value. Okay, so just for the calculation purposes, I am choosing it as 75. Now, what is my next class limit? To get that, you will be add the class width. What is the class width? It is 50. So add the class width and you will get 125. Okay, now again repeat the same thing. Add, you will get 175. Add the class width, 225. is 275. Okay. Okay. So now, how do you know that you have to stop at a particular number? Now I stopped at 275. Why? Because if you now just say that if you add again the class width for this number, your answer will be 325. Okay. But come back to the table. What is your maximum number? It has to be 308. That's your maximum number given. Now if you add 50 to the previous value, it will exceed your maximum value, right? And that is why we will be stopping it here. We'll be stopping at 275. When you add 50 there, it is going to exceed the maximum value, and that is why we are stopping at 275. Okay. Okay. Now, how to find the upper limit? Once you find the lower limit, next is to find the upper limit. Okay. So, upper limit will always be choose this number, take this number, and your upper limit will be 125 minus 1, which is equal to 124. Okay, this number minus 1 will be equal to 125. Likewise, you can just find out the upper limit of the next classes. Will be 175 minus 1, 174. This will be 224, 274. And next, how do you do this? How do you find this number? This number will be 274 plus the class width, which is equal to 324. Okay, this is how you find out the class limit. Next is to find a frequency, right? Next is to find a frequency. So before you find a frequency, let us do tally. I'll tell you what it is. This is an optional step, but it will be very useful to count the number of data values for the frequencies. Okay, now let's go back to the table here. Now let's move downwards. Okay, now consider this data value 107. So 107 belongs to which class limit? Will be between 75 to 124, right? So 107 belongs to this class limit. I will take it as 1. 143. 143 is here. So I will choose this as 1. 100. Next is 100. 100 belongs to 75 to 125. So I will go back and I will write it as 1 again. Okay. Now again you have to do the same thing for all the values here. So when you do same thing for all the values, remember if 1, 2, 3, 4 and fifth number will be this. Okay, 1, 2, 3, 4, 5, scratch. Again 1, 2, 3, 4, 5, scratch 1. Okay, you will get 11 data values in this class limit. Fine. So in the same way you will be doing for the other problems, other class limits. So how do you count the frequencies? See, this is 5, right? The whole thing is 5. This whole thing is 5. 5 plus 5 is 10. Remaining is 1, so it will be 11. So 11 is my frequency. So likewise, yourself. Okay, so I will give you the frequencies number. It will be 11, 24, 10, 3 and 2. 11, 4, 10, 3 and 2. Okay, so this is how you construct the frequency distribution table. Okay, so this is how the frequency distribution table looks. Okay, now next step is to find the relative frequency distribution and cumulative frequency distribution. Now what is it? So the relative frequency is nothing but the portion or a percentage of data, portion or the percentage of data that falls in that particular class. Okay, now how do you find this relative frequency? You are going to divide a frequency, right? Frequency f, you know that, right? So frequency will be divided by the sample size. What do I mean by sample size? Sample size is nothing but your sum of all frequencies. So this is also denoted by summation of f. This is nothing but your summation symbol, meaning sum of all. Okay, so sample size is nothing but your sum of all frequencies. Okay, now if you express this value in a percentage format, which means you will be multiplying that with 100, then that is called your percentage frequency. Okay, so next is cumulative frequency. What is cumulative frequency? It is nothing but a sum of the frequencies of that class and all the previous classes. So the sum of the frequency of the last class, how do you verify that? So sum of the frequency of the last class must be equal to the sample size, which means the sum of all frequencies. Okay, and you can write the relative frequency as a fraction, decimal or a percentage. And your sum, just keep this in mind, that the sum of frequency of relative frequencies and the cumulative frequency of last class is equal to summation f. Okay, let's see an example if we have. So let us calculate the frequency, relative frequency and cumulative frequency using this example. I'm just going to rewrite the same thing. So what is the formula for relative frequency? It will be frequency divided by sample size, which is sum of all frequencies. So what is the sum of all frequencies? Summation f or n, 11 plus 24 plus 10 plus 3 plus 2. You are going to add all this and you will get it as 50. That is the sum of all frequencies. Okay, so this will be 11 divided by 50, and this is going to be 24 divided by 50, 10 divided by 50, and 3 divided by 50, and the last one is 2 divided by 50. So your answers must be 0.22, 0.48, 0.2, 0.06. You can use calculator and calculate the value for this. So this will be your relative in decimals. What if I want to express the same thing in a percentage? So let this be a relative percentage. So this is going to be 0.22 into 100. Okay, you just have to multiply that with the 100. That will be 22, and this is going to be 48. This is going to be 20. This is 6%, and this is 4%. Now next is to find the cumulative. So while calculating the cumulative, start with the first value of the frequency. First value of the frequency will be here. Okay, start with the first value of the frequency and then add 24 to this. Okay, so this is the second value of the frequency. Take the first value, add it with the second value, you will get 35. And now you will take the next value, which is 35, add that with the third frequency, which is 45. In the same way, 45 here, plus add it with 3, you will get 48. And now this will be 48 plus 2, which is 50. Okay, now observe this carefully. This 50 is nothing but your sum of all frequencies. Okay, so the last class, the value of the cumulative frequency of the last class should be equal to the sum of all frequencies. Okay, and this is how you calculate frequency, a relative frequency, in terms of fractions, in terms of percentages, and also this is how you compute the cumulative frequencies. Okay, and now next is about normal distribution. So we will be learning about this in detail in our next chapter, which is a very important concept. Normal distribution is a very important concept. How does this look like, or what is the other name for this? It is also called as bell-shaped graph. Okay, it is also called as bell-shaped graph, which means your normal distribution should look like this. As the name says, your data must be normally distributed. Data must be normally distributed. Normally distributed. it says that your data is normally distributed. Remember, the data should increase up to a certain maximum point and then it has to decrease and go back to the same lowest point. This is the lowest point and this is the maximum point. If that happens, we say that data is normally distributed. Data is normally distributed. Okay, so observe this, that the graph, the curve of this graph and this graph is symmetric. It has to be symmetric in case of normally distributed. Okay, so the frequencies start low and then they increase to some high frequencies and then they decrease to a and they go back to a low frequency. Okay, and the distribution is symmetric. In other words, I say that this is like a mirror image of the other one. Okay, so this is called as normally distributed or a bell-shaped curve, or we say graph. Next, gaps. So it is simple that if you find anything, so in a frequency distribution table, sometimes you also find a zero value here in a frequency column. So that means that there is a gap in the frequency distribution table, in turn meaning that these data are collected from two different populations. These data are from different populations. These data are from different populations. So when there is a gap in the frequency distribution table, it means that there is a data from different populations, from two or more. It can be two, it can be two, or it can be three. It can be more than two. Fine. Next is comparison. So when you combine two or more relative frequency distributions in one table like this, it makes comparisons of data very or much easier. So data can be compared easily when you combine two or more relative distributions. So this is a complete different survey and this is a complete different survey. Now these values are nothing but your relative frequency distribution, or I say relative frequencies. Okay, which is a complete different survey. And now we say that we are comparing the relative frequency of McDonald's with relative frequency of Dunkin' Donuts. Okay, this is called as comparisons. So that it will be very easy for us to come at a point of conclusions. For example, here we can say that the Dunkin' Donuts service times appear to be lower than those at McDonald's. Okay, so when you compare these two, we can say that the service time of Dunkin' Donuts is lower than at McDonald's, right? So it is very easy to conclude or to come to a conclusion when we compare the data of two surveys. Okay, so that's your section 2.1. So now there is an example here. So this is for you. Okay, but I will give you values, solutions, final values. First is summation of F, 30, and next is class width. You will get a decimal value which will be around 55.86, and you can round it off to 56, or it can be 60 also. Okay, it can be 56 or 60. And what else? And remember, summation of f by n, which means the sum of relative frequencies should be 1, or it has to be 100%. And summation of cumulative not the summation but the last class of cumulative, or the last value, should be 30. Okay, so identify the lowest value and the highest value, and then create a class. Remember, how do you create a class? You will take a lowest value, add the class width for that, and you will get a second class limit. Likewise, you go on, you keep on doing. So once you find all the class limits, you are going to tally, or you're just going to find the values. For example, 90 fits in which class limit? So find that, then you get your frequencies. Okay, and after that you are going to find the relative frequency and as well as cumulative frequencies. Okay, you will be finding what you have to compute the you will have to find the frequencies and relative frequency, cumulative. So this is about your section 2.1 frequency distribution table.